Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today,
All right.
imagine this. You're building an AI system and memory is your biggest bottleneck. Not compute, not models, but how you store and retrieve knowledge efficiently. Today, we are diving into a fascinating idea from the Memvid project, inspired by the paper and implementation by Omar Khattab and team, where memory isn't just stored, it's compressed into video. And yes, actual video. So here's the problem. Modern AI systems rely heavily on vector databases. They're fast, but expensive, memory hungry, and not always scalable. Now imagine you want to store millions of embeddings. Costs go up, latency increases, and deployment becomes painful. What if, instead of storing vectors traditionally, you encode them into something highly optimized already, video compression? Here's the core idea, and it's surprisingly elegant. Memvid takes high-dimensional vectors and transforms them into image frames. These frames are then stitched into a video, leveraging modern video codecs like H.264, which are insanely good at compression. So instead of storing raw embeddings, you store a compressed video file. Then, during retrieval, you decode only the relevant frames and reconstruct the vectors. Think of it like this. A vector database becomes a film reel of knowledge. You don't scan everything, you jump to the right frame. And here's the wild part. The benchmark highlights show massive compression ratios, competitive retrieval accuracy, and significantly lower storage costs, all while keeping performance practical. Now let's talk architecture. There are a few key steps in the pipeline. First, embeddings are generated normally, nothing changes here. Then, they're quantized and mapped into pixel values. These pixels form image frames, multiple vectors per frame, arranged spatially. Next, frames are encoded into a video file. At query time, you don't decode everything. Instead, you use indexing metadata to jump directly to relevant segments, decode selectively, and reconstruct approximate vectors. You can plug this into existing retrieval systems or even hybrid setups with traditional vector DBs. So it's flexible, not a full replacement necessarily, but a powerful optimization layer. Let's pause for a second. Why does this work so well? Because video codecs are optimized for redundancy, spatial similarity,
Temporal compression.
and guess what embeddings have? Patterns, clusters, redundancy across dimensions. So instead of fighting compression, Memvid leans into it. It's like using a tool built for movies to store knowledge graphs. Now, let's talk benchmarks. This is where things get really interesting. Memvid shows orders of magnitude reduction in storage, comparable recall in nearest neighbor search, and efficient decoding for retrieval. And in many real-world applications, that's a very good trade. All right, pitfalls. First, compression introduces approximation. So, if your use case needs exact vector matching, this might not be ideal. Second, decoding overhead exists. If not optimized, retrieval latency can spike. And third, tuning matters. Frame size, quantization, encoding settings, they all affect performance. Practical tip: start hybrid. Keep a small high precision index and offload bulk memory into Memvid. That way, you balance accuracy and efficiency. And honestly, this opens a bigger question. If embeddings can live inside video, what other data structures are we underestimating? That's something worth exploring next. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.